Okay, I figured it out. So going from where we left off, we simulate the data for 10,000 times. And our data set mean that we have in front of us is 0.159, which is also shown as a blue line on this graph. So if there was actually no, if the mean was actually zero of the difference data set, uh, but it was still shaped, based on what we actually see, but just around centered on mean, then basically 70. Let's see. Uh, let's rerun this. Wrong direction. Then for us to say that this is a truly significant positive mean, that uh, we would need 5% confidence, or like they say p-value of 0.05. Here we have not 5%, but 30% of the time. If we kept if we kept redoing this experiment, we'll have the just mean at random based on this estimated distribution that will be that or bigger than 0.159. And 60% of the time, if you multiply this by 2, that mean absolute of that mean will be different than 0.15, because in this distribution there's 60% of the time it's on this side more less than 0. minus 0.15, and or it's bigger than 0.15, so two-tailed. It's 60% of the time it's in that range anyways. um, so that's not good. That's not good enough. That basically we need more data. So we need more data, which will make this thinner, which will basically mean that there's a lower chance that we'll see any value that's bigger than what we're seeing, than 0.15. But right now it's 30%, which is way more than 5%, which is what we would want to be relatively sure that there's an effect that of 0.159 or more. Then we move on to this. So we basically plot um, that what we would see in the mean, and this is multiplied by 20, right? No, divided by 20. Yeah, so here it would be 0.5, so it's divided by 20. So if we actually saw 0.5 difference, it would be pretty big compared to our data, such that at 0.5 we would be at like 4% confidence level. So if we kept rerunning this data only 4% of the time, by chance and random chance alone, we would get a value that is bigger than 0.5, approximately, like in this one tail. So there's only 5% chance of us getting it by a random chance that is like that if we do like one tail test. So basically that shows that like we would have had to see an average of 1 basically, or 20 somewhere here, for like a 1%. But like for 5%, we basically would need to see an average of like point. So this is 6, so divided by what, 20, 0, 0.3. So 0.3. So we would need to see an effect of 0.3 to say that, yeah, there's no way that by chance we would get that big of a difference or more.